Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to condense logarithmic expressions. Before we get started, we're going to take a look at the formulas that will be guiding our problem-solving process for the examples that we're going to be looking at today. So let's go ahead and take a look at the formulas. So the formulas as follows. The first one is the product property of logarithms. Okay, so if you have the sum of logarithms, let's say the common log of a plus the common log of b, this can be condensed into the logarithm of the product of the logarithmic arguments, which is a times b. Okay, so just remember that this is one of the main reasons why logarithms were created. It helps convert product problems into a sum. So you just find the sum of the logs and take the inverse log to generate the product. Okay, so this is the common log representation. The same procedure applies to natural log also. So if you're looking for the natural log of a plus the natural log of b, using the product property, this can be condensed into the natural log of a times b. Alright, and then for difference, the common log of a minus the common log of b, this becomes the common log of a divided by b. The same applies to the natural log of a minus the natural log of b. This can be condensed into the natural log of a over b. So these are the quotient properties of logarithm. Alright? And then we have the power property. If you have a coefficient in front of your log, let's say we have a, for example, of the common log of b, you can power up your coefficient to become a power of your logarithmic argument. So this becomes the common log of b raised to the a power. Okay? And if a were a reciprocal, let's say a were a fraction, 1 over a, for example, and you want to take the common log of b multiplied by 1 over a, the same procedure can be applied here. This coefficient can be expressed as a power, so you can power up the coefficient to the logarithmic argument b, and write that as log of b to the 1 over a. Remember, these are common logs, so you have an invisible 10 here. Okay, so if you have a log without a base specified, it implies that the base is 10. Okay, so you don't normally write down the bases if the log is base 10 for common log or base e for natural log. So ln has an invisible base, which is base e, but you don't write those down also. Okay. So this logarithm here has a rational exponent. It can be simplified further into log base 10 of b raised to the a root. Okay, so the eighth root of so the log of the a root of b. So this is how you write it. Okay, so let's go ahead and keep these formulas in mind. Let's title them as we go through the examples. So this is product. This is quotient, property of logarithm, and this basically are the power property of logarithms. Okay? Alright, let's take a look at some examples. Alright, so the instructions are for us to condense the following log expressions. Okay, condense the following log expressions. Alright, number 1. What if we have log base 3 of x plus log base 3 of z? Alright, so to do this, we have the sum of two logarithms. So log base 3 of x plus log base 3 of z. We're going to use the product property. Remember, when you're adding logs, is the same thing as finding the log of the product of the logarithmic arguments. Okay, so this plus is going to become the product of these two logarithmic arguments, x and z. So this is going to basically become condensed into log base 3, and then you just multiply the logarithmic arguments x times z, And that, ladies and gentlemen, is your final answer. Alright, let's take a look at number 2. Let's say we're dealing with a natural log in this case. So we have the natural log of 7 minus the natural log of y. So remember, when you're dealing with natural logs, the implied base is e, the natural base e. Okay, so irrational number 2.71 and goes on forever. Alright, so we have the natural log of 7 minus the natural log of y. We're going to be using the quotient property here. So the sum of the difference of two logarithms is equivalent to taking the logarithm of the quotient of the logarithmic arguments. Okay, so 7 and y are the logarithmic arguments. So we're going to be expressing this natural logarithm in a condensed form, which will be the quotient of these two. So the one that comes first is going to be the numerator, 7, and the one that comes second will be the denominator, y. Okay, so that will be the natural log of 7 divided by the natural log of y. Alright, let's take a look at another problem, question 3. What if we want to find 3 times log base 2 of 3x plus 4? Alright, let's take a look at this one. So we have 3 log base 2 of 3x plus 4. Now, using the power property of logarithms, we can power up this coefficient of the log. So this becomes a power of the logarithmic argument, which is 3x plus 4. Alrighty, so this becomes log base 2 of the logarithmic argument 3x plus 4 raised to the third power. And that, ladies and gentlemen, is the condensed form. Alright, let's take a look at question number 4. Now, what if we have 1/3 of the natural logarithm of x squared plus 3, and we want to condense that. So in this case, we're dealing with the natural logarithm and a fractional coefficient. So how do we do this? Well, we're going to be using the power property again. So the power property of logarithms enables us to power up the coefficient to become an exponent of the logarithmic argument. So this is going to become the natural logarithm of x squared plus 3 raised to the 1/3. Okay? Now, since the power is 1/3, we can rewrite this using the property of exponents. If you have a rational exponent, we can rewrite that as the natural log of the base of the rational exponent becomes the index of your radical. Alright, so it becomes the third root of your logarithmic argument, which is x squared plus 3. And that is your final answer for question number 4. Okay, let's take a look at question number 5. For number 5, let's say you want to find log base 2 of x minus 2 times log base 2 of x minus 1. Okay. Alright, we want to condense that. Alright, so we have log base 2 of x minus 2 log base 2 of x minus 1. Now, before we condense these two, we have to make sure that they are identical logarithms, okay? With no coefficients. This has a coefficient that has to be addressed. To clear out this coefficient, we're going to use the power property of logarithms to power this up. This becomes an exponent. And we have log base 2 of x minus log base 2 of x minus 1 raised to the second power. Okay, now that we have identical logs without coefficients, we can go ahead and apply the appropriate property, namely the quotient property of logarithms, because we have a minus. Okay, we express this logarithmic arguments as a quotient. Remember, when you're subtracting logs, is equivalent to finding the quotient of the logarithmic arguments of the logarithms that you are subtracting. Alrighty, so this becomes log base 2 in the condensed form. The first one goes in the numerator, divided by the second one, which is x minus 1 square. Alrighty, so this is basically the answer for question number 5. Alright, let's take a look at another example. Question 6. What if we are to condense the natural logarithm of x plus 3? Now we have a binomial as a logarithmic argument, a linear binomial minus the natural logarithm of x minus 3. Okay, so how do we go about doing that? We have the natural logarithm of x plus 3 minus the natural logarithm of x minus 3. So we're going to use the quotient property again. So remember that when you have a difference of logarithms, you can express that difference as a quotient. So minus becomes the quotient or division of the logarithmic argument. Alrighty, so let's go ahead and write down the answer. So this becomes the natural logarithm of the first logarithmic argument. The first one is going to go on the top, and then the second one is going to go on the bottom. Alright, so the quotient of those two. So it's going to be the natural logarithm of x plus 3 divided by the natural logarithm, divided by the quantity x minus 3. Okay, so that's basically your final answer. Alright, let's take a look at problem number 7. So question 7. Alright, so before we attack number 7, let's take a look at number 6 again. Now, one thing you want to avoid doing is the urge to divide out the x's or the 3's. Now, why is that the case? If you look at x in the numerator and the denominator x and 3 are combined by plus. Okay, the inverse of addition is subtraction. So if you want to get rid of 3, you have to subtract 3. If you want to get rid of positive x, you have to subtract positive x. Okay, and then in the denominator, to get rid of negative 3, you have to add 3. To get rid of positive x, you have to subtract x. Alright, so if you want to reduce, you can only reduce terms that are common factors of every term in the numerator and every term in the denominator. Okay, that's what the greatest common factor is for the numerator and denominator. There are no common factors in the numerator that is common to the denominator other than 1, so nothing can be cancelled out. So for example, let's say we had something like this. Let's say we had a 3 here and a 3 here. Now what you notice is that every term in the numerator has a common factor of 3. Okay, and every term in the denominator has a common factor of 3. So you can then just divide every single term by 3, or factor out the 3 from the numerator and the denominator and divide those out. Alright, so bottom line, avoid dividing terms that are combined by sum and differences. Factor it out first, and then you can divide out products of terms. That's how it works. Alright, so let's take a look at number 7. Let's say we have to find the condense the following logarithmic expression: 5 log x plus 3 log y minus 2 log z. Okay, this one is a little bit more complicated because now we are dealing with 3 terms, okay, 3 logarithmic terms. So how do we go ahead and condense this? Now, first thing we want to do is we want to make them uniform. Okay, we want to make them uniform, basically logs with no coefficients. So we have to address the coefficients first. What am I talking about? Well, this 5 and this 3 and this 2 are the coefficients of the 3 logs. That needs to go in order for us to apply the product and quotient properties of log. Okay, so how do we accomplish that? Well, we're going to use the power property of log first to power up these coefficients, make them into the exponent of our individual logarithmic arguments. So this then becomes log of x, of course, is base 10, x to the 5th power plus log base 10 of y to the 3rd power minus log base 10 or the common log of z raised to the second power. Now you see this is nicer because we don't have any coefficients and they all are logs of identical bases. To condense, it's advisable to do it 2 at a time so you don't get yourself confused. So we're going to do the first 2. We're going to go from left to right, okay? So on the left side, we're going to condense these 2. Remember your product property of logarithms. The sum of logarithms can be expressed as the logarithm of the product of the logarithmic arguments. In this case, the logarithmic arguments are x to the third and y to the third. Alright, so plus is going to become times. We're now going to have the common log of log base 10 of x to the third times y to the, oh wait a minute, I changed something here. This is supposed to be 5. My 5 changed into a 3. Sorry about that. Let's fix that real quick. So we have this is a 5. So we have x to the 5th power, y to the 3rd power. Okay? So we have that minus the log of z squared. Now we have 2 terms, much better. We are now going to use the quotient property of logarithms because we have a difference, and this minus is going to become a division to finish this off. So our final answer will be log of, we're now going to write this as the quotient of our logarithmic arguments, x squared, x to the 5th times y to the 3rd, and z squared. So that's going to become x to the 5th, y to the 3rd, divided by z squared. Ladies and gentlemen, that is the final answer for problem number 7. Alright, let's go ahead and take a look at the last example, which is question number 8. Let's say we had to condense the logarithmic expression log of x, so the common log of x minus 3 times the quantity common log of x of the quantity x minus 3 plus the common log of x, the quantity x plus 3. Alright, okay. So let's go ahead and condense this logarithmic expression using the properties of logarithms. Okay, so log of x minus 3 times the quantity log of x minus 3 plus log of x plus 3. Alright, so first things first, we want to make sure that we all have the identical logarithms without coefficients. That's not the case here. What we have here is we have a 3 in front of this sum right here. Okay, so 3 has been multiplied by these logarithms. So what we're going to do first is we are going to distribute this 3 to the individual logarithms. So just distribute the 3 here and then distribute the 3 there. Okay, you do not want to power up, put the 3 here because it's as a product of this sum, is not a coefficient of a logarithm. Alright, if you want to power up, you must have one and only one logarithm next to the coefficient before you can power up. We have a sum of 2 logarithms, so you can just power up this to that right there. Okay, so let's distribute, then you see exactly what I'm talking about. So we have log of x minus 3 log x minus 3 plus 3. Okay, let's hold on for a second. What we're doing is distributing negative 3, so we have to be careful. Alright, so we're distributing negative 3. So let me make sure I make this explicit here. So we're not just distributing 3, we're distributing negative 3 to these two terms. So we have negative log base 10 of x minus 3 plus, and then when you times plus by negative 3, it becomes negative 3. Okay, so minus 3 log of x plus 3. Okay, so now we're going to go ahead and start to condense. We're going to do it 2 at a time. Let's start from the left to right. Okay, so we're going to condense. Now, before we condense, how about we clear out the coefficients. Okay, if we clear out the coefficients, it will make the the condensing process much fluid. We can combine and then condense, but if we get rid of this coefficients first, then we're going to save ourselves a few steps. So let's go ahead and clear out our coefficients, make the logarithms all identical, so we just focus our energy on just applying the quotient property of logarithms. Okay. All right, so if we do that, we are now going to have log base 10 of x minus log base 10 of x minus 3 raised to the third power minus log base 10 of x plus 3 raised to the third power. Okay, so we now have log base 10, log base 10, log base 10, identical logs. Let's proceed with condensing the first two together using the quotient property because we have a difference. If we condense those two, that's going to yield log of the quotient of the logarithmic arguments. In this case, our logarithmic arguments are x and the quantity x minus 3 raised to the third power. Okay, so this will become x divided by the quantity x minus 3 raised to the third power. Okay, alright, this minus log of x plus 3 to the third power. We are now going to apply the quotient property again because we have two logs that have been subtracted from one another. So we're going to condense them into the logarithm of the quotient of the logarithmic arguments. Okay, so we have this monstrosity over here that will be the denominator minus this argument right here, x plus 3 to the third. Alright, so this is going to become x over x minus 3 to the third. Okay, so this one that we have right here, we're going to be dividing it by divided by x plus 3 to the third. Okay, like that. Remember, when you're subtracting logarithms, is equivalent to the logarithms of the quotient of the logarithmic arguments. Now you might wonder, why did I write it horizontally? It doesn't really matter how you write it, but whichever way, we will have a complex fraction which we have to simplify. Okay. Alright, so now this denominator, this divisor here, I can write it as a fraction, put it over 1. Okay. Now remember how to divide fractions. When you're dividing fractions, you just multiply the numerator or the dividend by the reciprocal of the divisor. Alright, remember, drop, change, flip, or keep, change, flip is the same thing, right? So you keep the dividend, so you keep this, or the numerator, x over x minus 3 to the third. You keep that, or you drop it. You change your division to a times, and then you reciprocate your denominator or divisor, so this becomes 1 over x plus 3 to the third. Okay, so that's how you divide fractions. We're just extending that idea over here. Okay, alright, and then just multiply across since these are fractions. Numerator, x times 1 is just x divided by the denominator, x minus 3 to the third times x plus 3 to the third. You can proceed to factor out the powers from the denominator. Is exactly the same thing. Okay, so this is the logarithm in the condensed form. Okay, so you can write it like this, or if you want, you can write it as the common log, or log base 10 of x over x minus 3 times x plus 3, both of these raised to the third power, like that. Bam, and then the logarithm of that entire thing. These two are exactly the same. Both are correct. Alright, so this is basically how you condense logarithmic arguments. So which property of logarithms do you prefer the most? Product, quotient, or the power property? Let us know in the comment section of which property you prefer the most, and let us know why you prefer that particular property. Thanks so much for taking the time to watch this presentation. If you have not already subscribed to our channel, go ahead and do that. We upload videos to our page on a regular basis. So if you want to get notifications of those uploads, just subscribe to our channel. If you have any questions or comments concerning this presentation, or if you would like to request a math video for us to do, just post your comments in the comment section below. Let's know what you want or think. We'll appreciate that. And don't forget to give us a thumbs up to support our page. Tons of resources can be found at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.